In today's lesson, we are going to add on 2 more of the 5 congruence theorems and postulates for this unit. If you'll recall from the last video and last class, you learned about the theorem side, 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 which said that if you could show all 3 pairs of sides in one triangle match and are congruent to all 3 pairs of sides in another triangle, you could say those triangles were congruent because of side, side, side. We abbreviated it obviously as SSS. Today we add on 2 more theorems. One of them is called side angle side, and we abbreviate it as SAS. And so if you'll notice the order of the letters, notice that you've got 2 sides and then an angle in the middle. The reason why it's listed that way is because the angle must be included between the 2 sides. It cannot be a non-included angle. So for example, my 2 triangles I'm drawing here on the right-hand side, if I label one side there and one side there, and then this angle in the bottom left corner, that would be included, or that would be called an included angle, because that angle is formed by the 2 side lengths that are marked congruent. If I label the same 2 sides as congruent in this second triangle, and instead label this top angle as the congruent one, notice that the 2 sides that make the 2 sides that are congruent do not make that angle. Therefore, that is called an unincluded angle. That is not SAS and cannot be used as a congruence theorem or postulate. So what you're still looking for, if you notice, is 3 congruencies. Instead of looking for 3 congruent sides in these problems, you're instead looking for 2 congruent sides and an angle in between. Now, if we scroll down a little bit, we notice that there's a second theorem here. It is called hypotenuse leg congruence. HL requires 3 things, just like the other theorems. However, it only requires 2 congruences. Now, the third piece of information you have to know is this that I'm circling. You have to know that the 2 triangles you're looking at are right triangles. If this is not stated, you can't use HL. So at some point in your proof, you have to say that the triangles are right triangles if you're going to use HL. If you're not going to use HL, then you don't have to state that you have right triangles. But if you're going to use HL, you have to have right triangles. Also, notice that the H and the L stand for particular parts of the triangle. The H obviously is going to stand for the hypotenuse of the triangle. That would be the side length across from the right angle. And then the L stands for one of the legs of the triangle. So in this particular picture, BC and EF were the legs. We could have as easily said that AB and DE were the congruent legs, and it still would have been HL. So moving down, what we're going to look at is a bunch of pairs of triangles, and we're going to determine whether we have enough information to prove that they're congruent. And if we do, we're going to write a congruence statement. So the first thing we need to realize is just because this particular section is talking about SAS and HL doesn't mean that what we did last class gets thrown out the window. So it is still possible that we could have a pair of triangles that require side, side, side. Because as we go through this unit, we're adding on to what we already have, not forgetting what we already have. So if we notice, in my picture here, I've got 2 congruences. I've got these bottom sides that are congruent, and I've also got these right angles that are congruent. So it's possible that I could be looking at HL because I've got right triangles. However, if you notice, the hypotenuse of each triangle is not something that's already pre-marked, and in order to mark those 2 side lengths as congruent, we would have to have a math reason on why they're congruent. Unfortunately, we don't have a math reason why those are congruent, but we do have a math reason why this shared side down the center is congruent. Those are congruent because of reflexive property. Therefore, if you look at the information I have, I've got the shared side down the center, I've got the pre-marked sides from the beginning of the problem, and I've got these two right angles down here that are congruent. We learned a theorem a couple of units ago that said all right angles are congruent. Therefore, I do have three congruencies. Therefore, I can say that I have congruent triangles. So if I write my congruent statement correctly to make sure that all of the letters match, I can write that as an example. And when I write my theorem or postulate that I'm going to use, I'm actually using side angle side because I've got two side lengths that are marked congruent, and those side lengths form that angle. Two side lengths marked congruent, and those two side lengths form the angle. So side angle side. In the next problem, I'm given two congruencies to start with, a pair of sides and a pair of angles. So it appears that I'm going to be using side angle side. However, if we look at this side down the center as my shared side, I have a third congruence. Now here's the tricky part. In order to use side angle side, the angle that I'm looking at has to be in the middle of the two side lengths. And angle E over here is not an included angle between the two side lengths that are congruent. The included angle in this picture would be over here at G. Since I don't have enough information or any information at all to say anything about the angles at G, I actually cannot say these triangles are congruent because there's not enough information. Something to keep in mind. Someone in class asked the other day, is side-side angle a congruence theorem that we're going to talk about? And the answer to that question is no. That is never going to be a reason for congruent triangles. In order to use two sides and an angle, it has to be an included angle. So that's why it has to be written as side angle side, not side-side angle. Moving down. In the next picture, if you notice a couple of things. Number one, I've got a congruence here on the left and right. And a second thing, I've got this shared side down the center. That's a congruence. Now, if you look at where this angle is, these angles are right angles, but they're not included between the two sides. So side angle side is not an option in this problem. However, since triangle JKH and triangle HGJ are right triangles, since KH and GJ are two legs of the triangles, and the shared side JH is the hypotenuse of each triangle, we can actually say these triangles are congruent. So I've got JGH, and I've got triangle HKJ. And those triangles are congruent not by side angle side, but by hypotenuse leg theorem. Because I've got right triangles, I've got a single leg in each triangle marked, and I've got the hypotenuse of each triangle marked. So that's why we're using HL, not side angle side. In the next problem, notice that you've got all three pairs of angles marked congruent. There is not an angle congruence theorem. Angle is not a congruence theorem. And I'll repeat that again. AAA is not a congruence theorem. So just make sure that you're paying attention to the three pieces that you're finding, because if they're not the right three pieces, they're not helpful to you. So in order to find side angle side, you have to have two sides and an included angle. In order to use side side, you have to have all three sides. In order to use hypotenuse leg, you have to have a right triangle, you have to have the hypotenuse of each triangle marked, and you have to have a set of legs from each triangle marked. If the three pieces of information aren't one of those things, then it's not useful to you. We go to the next problem. Notice they start us off with two congruences, top and bottom, left and right. And then this third side down the center is a shared piece, which means that I do have congruent triangles. Those triangles being DEG, and we would say FGE. And in this case, the one from last class comes up, and we've got all three sides congruent, so they are congruent by side. In the next one, Again, we've got two congruencies, a pair of sides and an angle. If we're going to use side angle side, we would have to be able to show the other side that contains that angle. Unfortunately, the only other side length I can say that is congruent to itself is the side down the center. And if you notice, this again brings back side-side angle. So we've got side here, and then an angle that is not included. We've got a side here, and an angle that is not included. Anytime we see a picture like this, we have to write down that there's not enough information. In order to use SAS, the angle you would need, again, would have to be over here at G. Since there's not any information in the picture that would provide me enough to say that I have congruent angles there, I can't use side angle side. Flipping on the back, we're going to talk about a bunch of different proofs. A couple of them are fill in the blank. A couple of them are totally your responsibility to do. So remember, anytime we start a proof, the first thing we do is throw our given in. Remember that you're supposed to be looking for how many congruencies you start the problem off with. And in this one, you only start with one. That congruency is marked on the picture. Notice that from J to L and N to L are marked congruent. So looking at your picture, notice that in step 2, they make this statement. Angle JLK in the picture is right here, and angle NLM in the picture is right here. And if you remember back from a couple of units ago, we said that those angles would be congruent because of vertical angles theorem. Anytime you have vertical angles in a picture, they're going to be marked congruent. Notice the next step says we're going to use definition of a midpoint. And in the problem, it says right here in the given that L is the midpoint of KM. So if KM is here and L is in the center, that means that the distance from K to L has to be the same distance as from M to L. So that's exactly what we're going to state. K to L has to be congruent to M to L. So if you look at your picture, we have two side lengths marked congruent. And if you look at the angle marked congruent, it's between the two side lengths, which would make this a congruent triangle pair because of side angle side. Two congruent sides and an included angle. Moving down, first thing we're going to notice about this proof is that I'm given a couple of congruencies, and my job then is to find one more. So looking in the picture, you're looking for some obvious things. Do you have a midpoint in the picture? Is something bisected? Do I have parallel lines that would allow me to use things like alternate interior angles or corresponding angles and such? Do I have vertical angles in my picture? And in this case, I do. Those vertical angles are there in the center. And we remember we cannot call those just angle C because there's technically 4 angle C's in that picture. So we have to name those angles with 3 letters. And so I'm going to start at A, up to C, up to B. Angle ACB. And then the other one would have to start in the same direction, up at D, down to C, around to E. Angle DCE. And the reason why they're congruent, we said they're vertical angles. So VAT, vertical angles theorem. What we would then need to notice is that I now have 3 congruencies. I've got 2 pairs of sides and a pair of angles that are included. They're in between the sides. So I can actually say that I have congruent triangles now. And the picture looks very much like the one we did in the last problem. And those triangles are congruent because of side angle side. 2 congruent sides and an included angle. Moving down, in the next picture, first thing we want to realize is that we've got some given information. And in that given information, they start me off with 1 pair of congruencies. They tell me I've got RA and RG being congruent to each other. So the next thing that we want to look at is the fact that we have this thing that says perpendicular. That's what dr perpendicular AG, that's what that means. And what that tells us is that we have right angles in our picture. And that we know is because that's what perpendicular means. So I know those are right angles because of the definition of perpendicular. In the next step in the proof, notice what the third reason says. It says all right angles are congruent. Well, in the previous step, we showed that we have right angles. Well, if the next step says all right angles are congruent, then that would lead us to believe that we need to state that angle DRA and angle DRG are congruent to each other. So if you're looking for 3 different congruencies, we now have 2. They gave us 1, we just found another. Our third congruency comes from the fact that the side down the center, DR, is a shared side between the 2 triangles. So DR is congruent to itself DR, and that is the reflexive property. Anytime we see a statement like that, that's the reflexive property. Okay, so if we go through and look at all of the things we have, we were given a pair of congruent sides to begin with, RA and RG. We figured out that DRA and DRG were congruent angles because they're both right angles. And we also found that we have a shared side down the center, which is a third congruence. Once I have 3 congruencies, I can say I have congruent triangles. In this case, I've got sides that form the congruent angle, which means that, again, I'm using side, angle, side. Last one we're going to talk about is here. So first thing that goes in the proof is my given. And the first thing you would want to notice about your given is you're told that you have 1 pair of congruencies, and it is a pair of congruent sides. The other thing that you want to notice about this is that PR and SQ are in fact perpendicular to each other. And so what that means is I've got a pair of right angles in my picture. Those angles would be here that I'm labeling in purple. One of them would be angle PRS, and one of them would be angle PRQ. So all I'm going to state is that they're right angles. Okay, now here's why that's important. And the reason why is going to be definition of perpendicular. That's what perpendicular means. Those 2 sides intersect at a right angle. So let's talk about step 3 for a second. Step 3, we are going to say that I've got a obvious congruence right here down the center. And the reason why that's obvious is because it's a shared side. So PR is going to be congruent to itself, PR. And anytime we make a statement like that, we are going to say that's the reflexive property. Now here's the deal with the rest of the proof. If you notice, the 2 sides that I have marked congruent don't form the right angles. So I don't want to use SAS because that right angle is not an included angle. Therefore, instead of using SAS, I'm actually going to use what's called hypotenuse-leg theorem. Because hypotenuse-leg theorem requires 3 things also. Number 1, it requires that I have right triangles. Number 2, it requires that I have the hypotenuse of each triangle marked, which I do. PS and PQ are the hypotenuse of each triangle. It also requires that I have one of the legs marked in each triangle, which again I do. PR is a leg in each triangle. So here's the deal with this though. In order to say that you're using HL, you actually have to state that the triangles you're looking at are right triangles. I know that seems very trivial because we just labeled right angles in the triangles, but you actually have to state that they're right triangles. So what we're going to say is those 2 triangles are right triangles. And again, I know that seems stupid to have to state, but it is something that is required. Now, why are they right triangles? Well, they both have right angles in them, and that's the definition of a right triangle. So if you look at the things that we've stated in our proof, number 1, we have the hypotenuse in each triangle marked. Number 2, we have a leg in each triangle marked. And number 3, I was able to state that I have right triangles, which is necessary in order to say that I'm going to use HL. So I'm just going to recopy my congruent statement, PRQ and PRS. And the reason why they're congruent is because of hypotenuse leg theorem. As always, make sure if you have any questions about any of the problems that we've gone through on this video that you make a list of specific things that you can ask in class so that I can better answer those questions. If you have any other issues, just shoot me an email.